takes a couple seconds to start up. Color changing. Yes, this is Wilson.
Tell me what Wilson is designed.
He's designed more of the I never really programmed it before, so what I mean he is interested with
Oh, yeah.
How long does it take to freeze a 3D piece?
I'm not sure exactly how long. I think it might have taken like 6 hours. Yeah, and I don't think it's plastic. And I don't think he had it on the finest, and because the finest setting, because it came out on the web. But he said that if like you put it on the finest setting, it would take and also he didn't know how to do it at the time because he wasn't very familiar with the
I've got one case for something like
much you need to turn the motor in a certain direction so to balance itself. And the shimmer works by like it has a sensor reading of 0 to 1,000, and what you want is have it on 500, which is in the middle, perfect center it, and the way it works is right here. It lets the instrument reach from the sensor the value 0 to 1,000. And if it's on 500, it moves it does nothing, so it stays in the center. Or if it's below 500, it moves it backwards, which moves the motor backwards. And above 500, it moves it forward. The motor's sort of fast enough to keep it balanced, but the code works, so it tries to. So, like as you can see, like when it tips over, this goes that way, and it moves it forward. The motor's this way, so it tries to keep it balanced. And when it goes this way, when it tips over this way, it moves it the opposite direction. And I had to put a little training wheel so it was all over. And for some reason it didn't. The center is supposed to be like that for a 0, but it changed overnight after it was there. I had to use 2 H bridges to get the motor.
Do rolling because that's pretty simple. Just need to put it on the axis of the wheel. So I wanted to have it be able to move while walking. And when I first started out, the first thing I did was write the code for it. And I had the servos. It wasn't these, they were bigger ones. But I took one servo and I found out how to connect it to Arduino and write codes to control the and I ended up with a design where you have differential time intervals to angle they rotate, and they're sent a couple, it's like half a second apart for each turn, and then they're equal with the rotation. And
So does he really walk?
it did when I had it in the classroom, but on the only on the slip tables we had. What's the problem? Now, what I had, the problem I ran into, the very last problem, was the grip on the bottom. I tried with sandpaper first, or I tried with just wood first, and that was slipping, kind of just slip around. Then I tried with sandpaper, that worked alright, but I thought I could make it better. So I tried these rubber pads, and now the problem I have is when I put it on the table, it kind of just stays in place, and the servos aren't powerful enough to turn it around. So I've had it. It didn't move very fast when I did have it working, but it was moving forward, and it didn't work at all when I first tried because what I did was the base plate I had completely flat, and when it's flat, it kind of just goes in place. It wasn't moving forward, so I decided that if I had one incline, and what this does is it kind of acts to change the weight of it from side to side, and that gives time for these to push it forward depending on which side the weight's on. So it would alternate weight, like this foot and that foot would have weight, and then that foot and that foot, and it would slowly just back and forth go forward. But so I'm just wanting to work here.
I guess it's just not strong enough.
Yeah,
Too much friction.
yeah. So there's some design problems with that, and I couldn't make it better, but I ran out of time with that.
Now, what documentation do you have with you?
I only have
Again, I would take a piece of work from here to here, so the rod is never exposed, because if you just take the drum off, the rod is exposed, which is why it got bent. So if I had to build it again, I would make it so you could just pull the drum out, but everything else would still stay there. So the rod would be a little bit more protected.
The actual dimmer switch right here. See how it's really bright? You can't see the actual lettering. So we darkened that with the switch, and now you can see the lettering come across. And that was one of the big challenges of figuring out how to get the wording to appear on the screen. And so it worked out well. But here's the coding. This is the wiring between the LCD and also the Arduino.
Can I see it when you're
Over here, as you can see, the dimmer switch. There's obviously right there, and that kind of gave us the idea that that's how our screen was not working through the picture. So just a simple.
here in his case, it'd go down, up, down halfway.
So how did you avoid that problem with yours?
It should turn when I do this, but it doesn't because of a bit of.
So it was working at one point, and it did it's stuck where it is right now. I'm gonna fix it because I want it to work. It worked, but it was extremely slow. Stay where it is. And
Real fast.
power, I have 5 volt, and battery pack's wired directly.
I wanted to wait till I got to the one because that would happen. But once you get to the video,
positive and negative wires going to the ground and 5-volt pins on the Arduino. The green wire then goes into the analog green 0 pin, which sends the information to the Arduino. This is indicated right here on the program sheet. Now, this then indicates that the information is sent to pin 9, which is over here, and this information, the value read via the infrared sensor, is sent to the servo motor. Now, according to the value, like I said before, if it's too small, it'll come forward, if it's too big, it goes back. It's set at a very low value so that in a value as high as 150 or greater, the robot will move back. Otherwise, now, there isn't really a middle ground programmed in. I was very new working with Arduino code and I wasn't quite sure how to program in a middle ground as of yet, so he'll just sort of get jittery if he's not sure. Now, originally we had a push button system rigged up for this, but it takes a lot of voltage to run a single servo motor and an infrared sensor. So, this is here to show that we did have the push button. But to get him to actually work properly, we have the computer here as an external power source. Now you can see we don't have anything running on here. It's not even logged in. This is just here as a power source. It's not doing anything to affect the robot's function. So I'm going to plug this in, and it takes him a minute to figure out what he's looking at. Sometimes he'll back up just from light. But once he gets the idea that he's looking for people, so he's looking for a certain pattern, he'll function miraculously.
now it's getting more competitive. That's great because your guy has been done.
descriptions for that. You go ahead and try. He's not sure. Try putting your hand a little closer. Now, the smiley face on him and the ears.